So in this particular case, we have two functions here. It says use f of x, which is the square root of x minus 2, and the g of x, which is x plus 1. Starting with letter A, state the domain of f of x and g of x. So just the domain. What's the domain of f of x? So for f of x, the domain is x has to be greater than or equal to 2, right? Any number greater than or equal to 2. It can't be less than 2, because we're going to end up with a negative value, which we can't take the square root of a negative number. So it has to be 2 and over, right? What about the g of x? So x plus 1. Negative infinity to positive infinity, or we can say x is an element of real numbers, so or negative infinity to positive infinity. Okay? And I'll write down the other one too. It's going to be 2 to infinity. Okay? So we have both the set notation and the interval notation in that form. You can pick which one you like. Is everybody okay with that piece? Okay. So letter B, give m of x is equal to f of x plus g of x. So what's happening here is we're creating a new function, m of x, where it's basically combining of f of x and g of x by adding them together. So write an explicit equation for m of x, then determine its domain. So let's actually, I'm going to take the b down here. The m of x is equals to f of x plus g of x. So well, f of x is basically the square root of x minus 2 plus the g of x is x plus 1. Okay. So that's the explicit form of m of x. Okay, the actual equation. The second part of that is, what is the domain? So if you take a look at this, the domain here is greater than or equal to 2. But this one here, all real numbers. So if we add them together, what would be the proper domain for the combination of the two? 2 to infinity, right? Because when you look at this one here, okay, when we look at this one over here, we'll do the sketching later in a second. So the domain of g of x is from 2 to infinity, and then the other one is from negative infinity to positive infinity. They only overlap from 2 to infinity. Okay, so in here there's nothing for f of x. So here in this case, the domain for m of x, which is f of x plus g of x, is x greater than or equal to 2. Okay? Is that okay? Anybody have a question?
Will the domain in situations like this always be more restricted?
Yeah, it's going to be more towards a restricted. Okay. We're going to see that in a second when we graph it. Okay. Letter C. Letter C. So given the p of x, which is f of x times g of x, so now there is a new function, p of x, where it's basically a combination of f of x times g of x. So if we do that, f of x times g of x, so we're gonna, f of x, we know it's gonna be a square root of x minus 2 times g of x is x plus 1. Okay, so you can expand that if you want, or you could probably leave it like that. Okay. Now what's the domain for that one as well? It's also, so for p of x is x has to be greater than or equal to 2 as well. Okay, is that good? Now there's an optional part in here, and I think we could do it. We could do this without the graphing technology, okay? But it would require us to actually graph it on a graph paper and then do our evaluation of that. So I'm just gonna pass some graph paper around. Okay, so I'll put some over here. Take some and then pass it around. Pass it all the way to the back, please. That would be great. Okay, we'll start with letter B. Good, thank you. I'm going to take this, and this is for example 1. Now when we look at that one, we actually don't have a strategy for this. We have a strategy if we have to graph just x plus 1, right? Because that's just a square, it's an equation of the line. We have a strategy to graph this. Do we have a strategy to graph x minus 2, square root of x minus 2? We just finished doing that, right? We finished a transformation. So you graph square root of x, that's your parent function, and it's shifted to the right how many units? 2 units, okay? So we have a strategy just to graph this piece, and we have a strategy just to graph the x plus 1. But we never have had a strategy to graph that one yet. And actually, if you remember our first lesson, that's basically what we're going to be doing for this. Okay? So, we're going to need a pencil for this because we might have to do some erasures. Let's start with this one. Graph the function of the square root of x minus 2. How do we do this? Okay. So start off with the, okay, I'll wait. So So we're going to start with the square root of x. We know how to do that, right? Square root of 0. If x is 0, square root of 0 is 0, right? If x is 1, the square root of 1 is 1. Okay. Square root of 4, I'm going to jump to 4. 1, 2, 3, 4. Square root of 4 is 2, so it's going to be 4, 2. Square root of 9. So the graph kind of goes like this. Okay, we know that already, right? We remember that. Okay, I'm going to do it very lightly because that's not what we wanted as a final graph. We want it to be x minus 2. X minus 2. So it's going to be shifted to the right 2. Everything, every point shifted to the right 2. So this shifted to the right 2. Now it's right there. Every point shifted to the right. Now we can just erase the other one because that's not what we really wanted. Okay, so this graph is for f of x. So we're just going to label f of x. Okay, so far so good. F of x. Now, what's the other one? The other one is x plus 1. That's the g of x. How do we graph that? It's a linear function, yeah. So how do we start that? Y-intercept. Okay. Yeah, we could do the transformational here too, but or we can just jump right into this. Y-intercept is 1. Okay, so you can't see that, sorry. Y-intercept is 1, and what's the slope? 1 over 1. So from this y-intercept at 1, we go up 1, right 1, so that's our slope. Okay, so now we got both the g of x and the f of x on the same page. Can we add them now? Now, this is where the domain is restricted when we have to do the sum of these two functions. Can you see here, the graph is, there's no graph for f of x on the left side of 2. The graph is only up from 2 and to the right. So in this particular case, when we add them, there's nothing to add in here because it's just the g of x. So it's just going to be for these. Oh, okay. So our graph is going to be somewhere restricted between these two. Okay, so what do we do again? How do we do m of x? Yeah.
So that's 0 if x equals 0.
Okay, yeah. So we can say, we said our domain is restricted from 2. So this is x, has to be from 2 to 3 to 4 to 5 to 6 and so on, right? F of x, g of x, and if you combine them together, it's going to be f of x plus g of x. Okay. So if x is 2, what is f of x? F of x is this. If x is 2, what is f of x? 0? Yeah, 0. If x is 3, what is 1? Yeah. Is everybody okay with that? Yes? Okay. So if x is 4, so 1, 2, 3, 4, it's going to be square root of 4, which is 1 point. I'll just go square root of 4. Right. 1, 2, 3, 4. It's going to be, if x is 4, it's going to be 4 minus 2, so it's a square root of 2. 1 point something. 1.4. Okay, well, thank you. 1.41. Well, let's go 1.4. If x is 5, so you're going to put in 5 in here. 5 minus 2, which is square root of 3. 1.7. If it's 6, well, that's easy. It's going to be 2, right? So this is going to increase. Should we continue on? 7, 8, and 9. So this is going to be, if x is 7, 7 minus 2, so that's a square root of 5. It's going to be 2 point. 2.2-ish, okay, 2.2. And then if x is 8, we're going to plug in 8 in here. So 8 minus 2, that's going to be 6. So square root of 6 is going to be 2.4. And then if x is 9, it's going to be 9 minus 2, 7, 2.6. Okay. Good. Very nice. Is everybody okay with that? Now let's take a look at the g of x. G of x says if x is 2, what is the g of x? G of 2. It's going to be 3. If x is 3, what is g of 3? Okay, so this is going to be an easy one, right? Because it's going to be always x plus 1. So it's going to be 4, 5, 6, 7. Okay, now that we've figured that out, we can figure out the f of x plus g of x, which is basically 0 plus 3 is 3, 1 plus 4 is 4, 1.4, oh, 5. My goodness. This is going to be 6.4. This is going to be 7.7. 9. That's going to be 10.2. 11.4. This is going to be 12.6. Okay. How do you like it? It's pretty easy? Yeah? Okay, good. I know it says there, use graphing technology, but we have the skills to do this by hand. And we can take a look at the graphing technology later, see what it looks like. Okay. Yeah, so go ahead. I know you're already plotting this, so I'll do the same thing. Does your graph kind of look like what I have in front?
I think the 1 point's a little low on the first one. 2 or 3?
Did I do 0, 3, 0? No, 1, 2, 3. Oh, that is low. Yeah, so that has to be here. 2, 3. So we have the f of x, we have the g of x. Now this one here is the m of x, which is the combination of those two. Okay, good. So far so good? Yeah? That's pretty easy, right? And, you know, I know that some of you have Desmos, so why don't somebody type it in onto their Desmos? So I didn't bring my phone here. And let's take a look. See if we got it right. You're trying? Okay, can I just borrow that? Because I know some of you have it. Okay, so this is what the Desmos look like. And this is our freehand graph. And I put an arrowhead at the end, and is everybody okay with that? Does that make sense? Yeah, because they're both, thank you, they're both going to continue on, right? So it's going to keep increasing and increasing. Now, before I forget, I just want to make sure that I told you this, because you're going to get a hand-in assignment later on. Well, not today, but tomorrow. And some notations in here. So I want to make sure that we understand. So f of x plus g of x, okay, that's what m of x is, right? There's another way to write that form. We can write it as brackets f plus g, close bracket, x. So I want you to be familiar with both ways of writing things. So you can write it as f plus g of x, which is the same thing as f of x plus g of x. Good? Because you might see an assignment that's like, oh, we didn't learn how to do this. Like, it's just a different way of writing. Okay, very nice.
You can't put m of x?
Oh yeah, you can. Yeah, you can go m of x, which is equal to that, but another way of writing that is that. Good? That's pretty fun. Okay, let's see this one. Example number 2, use f of x, which is negative root of x, plus g of x, which is x plus 2 squared. State the domain of f of x and the g of x. So let's do that first. Actually, I'm just going to bring it down in here so I'm not crammed. So f of x. What's the domain of f of x? It has to be, in the number, the radicand has to be a positive value. Otherwise, we can't take the square root of a negative, right? So it has to be, can it be 0? Yeah. Less than, yeah. So it's going to be negative infinity to 0. Okay. Negative infinity to 0. Or we can say x has to be less than or equal to 0. How did we do that? Okay, we kind of just thought about that and that's what we came up with. But then how do we know that? Oh, yeah. Oh, okay. I like that because you're thinking about this is the square root of x goes like this, right? And then because it's a negative b value, it's reflected onto the other side, so it kind of goes like that. Good. Very nice. Very good, looking at the transformation. Okay. Anything else? That's perfect. Actually, that shows a lot of imagination to be able to say that, yeah, to see that in your mind. Anybody else have a strategy on how to figure this out? Yeah.
Well, since it's a negative x, basically any number that's negative has, like, the x has to be, I mean, the number has to be negative in order to equal a positive.
Mm-hmm. Yeah, yeah. Okay, so that's what your idea is. Like, if this is already negative, and if I put a positive number there, overall it's going to be a positive radicand, right? So we don't want that. Overall it's going to be a negative radicand, sorry. Okay, another idea.
Negative one, negative number.
Okay, yeah, so yeah, okay, so it's pretty much the same thinking. Good. Okay. Anybody else before I tell you my idea? Okay. Okay. The radicand has to be a positive value or 0, right? It doesn't have to be positive only. It could be 0. So this one, negative x, has to be greater than or equal to 0, right? Now, in grade 11, when you did this inequality, they said that the rule, if there is a negative and you're dividing by a negative value or multiplying by a negative value, the direction of the inequality changes to direction, right? Or, when you think about this, if I bring this over here, that becomes x. If I bring the 0 over there, which is really still going to be 0, the inequality becomes that. Okay, so the x has to be less than or equal to 0. Okay, maybe some people remembered. If you're not sure about that one, I can make a little bit of I'll explain that in a different way later. Okay, so that piece has to be less than or equal to 0. 0 is okay, and negative number is okay too. Good. Now what about the g of x? What's the domain? Can you imagine what the graph looks like for this? It's a parabola shifted to the left 2, right? So it's a parabola. So what's the domain? Yeah, negative infinity to positive infinity, or we can say x is an element of real numbers. Okay? So given that, oh, we forgot a letter in here. We're gonna put a q in here. Okay. Given that q of x is equals to f of x divided by g of x, write an explicit equation for q of x, then determine its domain. Okay. So that's the B part. What's the explicit equation? So q of x is equals to p of x divided by g of x, or f of x divided by g of x. We said f of x is the square root of negative x. We said the g of x is x plus 2 squared. And that's the explicit equation or form of q of x. Good? That's probably one of the easy part, right?
So that's it?
Yeah, that's it. Yeah, we can leave it like that. Now, it says here, what's the domain? So here, the domain is from 0 and everything less than 0 for f of x. And then for g of x is from negative infinity to positive infinity. So the overlap would be x has to be less than or equal to 0. So for the q of x, domain is x has to be less than or equal to 0.
Can we just write the other way?
Which other way?
Interval?
Oh, yeah, you can do the interval. Yeah, that's okay. Negative infinity up to 0. Yeah. Okay, good. Do we have a strategy for this? Because now we have to graph it, right? Optional graph technology, q of x. So how do we do that? Okay, you still have your graph paper? Okay. So start graphing the square root of negative x. You know how to do that.
For g of x, how do you know it's up 2 and not left 2?
Oh, yes. We did say that. Left 2. We did say that earlier. Left 2. Okay. Okay, so we have these two functions. Now we're going to divide them, right? The quotient of those two. Okay. Now we're going to start at less than or equal to 0. So start at 0, it'll be 1, 2, 3, 4, 5, 6. That might be enough. Starting with the f of x square root of 0 is 0. Square root of a negative 1 is 1. Has to be negative. Negative 1, negative 2, negative 3, negative 4. Square root of negative 2 would be square root of 2. Square root of 3. Square root of minus negative 4, or negative 4 is 2. You can put the decimal approximation of those numbers. I just didn't have a calculator. Take a look at this next one. What's a g of 0? If we put 0 here, that's going to be 2 squared. That's going to give us 4. If x is negative 1, it's going to give us 1. If x is negative 2, it's going to be 0, because it's going to be 0 squared. If x is negative 3, it's going to be 1, negative 4, So far, so good.
Should 6 be 16? This negative 6 plus 2 is negative 4.
-4, 16, yeah. Okay. Now that we have all of these laid out, we can do f of x divided by g of x. So 0 divided by 4, 0. 1 divided by 1 is 1. Now for this one here, square root of 2 divided by 0, then this one would be the undefined. Undefined because we can't divide by 0. And then square root of 3 divided by 1, square root of 3. 2 divided by 4 is a half. So I'll just put 0.5. Square root of 5 divided by 9. We could have does anybody have an answer for this one? Square root of 5 divided by 9?
0.2.
Hmm?
0.4.
0.4?
0.24.
Oh, 24. And then the last one is 0.15. Okay, so I can see some kind of a trend in here. Okay, let's see if we can figure this out. Getting smaller, yeah. Getting smaller as we go. Okay, good. So if x is 0, so plotting here is if x is 0, the f of x divided by g of x is 0, so 0 is 0, so that's that point. If x is negative 1, the quotient is 1, so that's this point there. If it's negative 2, it's undefined. And it's undefined, so what can we do? That one, whole happens if there's a numerator divided by the denominator, if there's a common factor. So this one here would be asymptote. Undefined. If x is negative 3, it's going to be a square root of 3, which is 1.7. Okay, so probably around there. If it's negative 4, it's 0.5. If it's negative 5, it's 0.24. It's getting smaller and smaller. Okay. Can we see what the picture kind of looks like? It goes like this. Okay, if you have decimals, we can take a look at that as well. Do you have your decimals? one looks like what we have in here. Just gets smaller and smaller and smaller, and this one gets closer and closer to asymptote. Now, here's the other thing too. We have to be careful with the arrow sign, because here we don't need to continue on because we don't have any data or points on the right side of 0. So that one stays there. So this is a point there. But this one continues on. That carries to the top. This one is going to carry on up there. And like what you said earlier, it gets smaller and smaller and smaller. It's approaching 0. So this is going to be our f of x divided by g of x. Okay? Okay, so we do have some techniques to graph this by hand. We also have a graphing tool to use. Let's take a look at the last example. This one's going to be a lot faster because there's not much graphing in here. There's no graphing. So example number 3, consider the function m of x. And m of x is 2x squared plus 3x minus 7. Write explicit equations for 3 functions f of x plus g of x and n of x so that m of x has to be equal to the sum of all those 3 functions. Any possible solution for this? So we want to know what f of x is, the g of x, and the n of x, so that when we add them together, it adds up to 2x squared plus 3x minus 7. I'll give you one. It doesn't have to be super complex. Okay, so it could be 2x squared for f of x. What do you think the g of x should be?
3x.
Now you're seeing what I'm doing, right? 3x. And what's the n of x? Negative 7. So when we add these 3 functions, it would add up to m of x. Okay. What about letter B? Write explicit equations for 2 functions, just for 2, that m of x is equals to f of x minus g of x. Two x squared plus 3x minus 7, right? We want to know what the f of x is and the g of x. When we subtract these 2 functions, it's going to add up, or it's going to result to 2x squared plus 2x minus 7.
F of x could equal 2x plus 3x, and g of x could equal plus 7.
F of x could be 2x squared plus 3x,
Mm-hmm.
and then the other one would be
Plus 7.
plus 7. Okay, I'm gonna erase this part here because it's getting way too close. Right, so if you go 2x squared plus 3x minus a positive 7, it's going to give us a negative 7 over there. Yeah, that's right. There's probably many possibilities for this one, right? Okay, let's take a look at example 4. Consider the function p equals to x squared minus 2x minus 15 to x squared minus 2x minus 15. Write the explicit equations of two functions so that f of x times g of x will give us the p of x.
That's just like finding the binomials.
You have, yeah, so you can figure out the binomial times the binomial. It could be x minus 5x plus 3. So therefore f of x is x minus 5. The g of x is x plus 3. What about letter B? Given that q of x is x plus 3, write explicit equations for the two functions f of x and g of x so that the quotient will give us the x plus 3. So we know that this is going to be x plus 3.
So x minus 1 times x plus 3 over x minus 1.
That works, right? Because x minus 1 and x minus 1 will cancel, and then you got the x plus 3 as a result. Nice. How do you like that? It's okay? So it starts off very, very friendly in terms of graphing, in terms of writing the explicit equation. We're going to pause here. And then take a quick break. When we return, we can work on some of these questions, and then I will give you back your test. Yes.